Even the Arctic's most resilient ice is more vulnerable to melting than scientists thought. Here's what you need to know. A huge hole has been discovered in the Arctic's oldest and thickest ice, previously thought to be the most stable ice in the region. According to a study published in the Nature Geoscience journal, there was a powerful storm north of Ellesmere Island on May 2020, and a long narrow crack formed on May 14th. By May 15th, the crack had formed into a polynya, an area of open water in a region that is normally ice-covered, around 30 kilometers wide and 100 kilometers long. With ice around 4 meters thick, this Arctic ice is predicted to be the last to remain in place during summer melting seasons, but the study emphasizes it's surprisingly vulnerable to cracks. In the short term, newly open areas of ocean water can create ideal conditions for life, but as ice melts and moves offshore, species like walruses and seabirds lose access to it, and eventually it becomes so hot that species can't survive. On May 26, 2020, this particular polynya rapidly closed, but the study's lead author warned in a press release that polynyas may become more common or larger in the future because as ice gets thinner, it's easier to move around, and the study itself points out that previous storms in the same area had caused smaller cracks, which may be because the ice has already thinned. The study details how warming makes ice thinner, and thus more vulnerable to cracking, and how for the same reason the ice is increasingly less likely to reform, but a previous study in the Proceedings of the National Academy of Sciences explains, more fundamentally, how ice melting is a vicious feedback loop. First, melting lowers the height of the ice sheet, then it is exposed to the warmer air found at lower altitudes, and that in turn causes further melting. One co-author of that study said its findings show destabilization of this ice sheet is already underway, and there will be substantially increased melting in the near future. He added that the ice equivalent of 1 to 2 meters of sea level rise was probably already doomed to melt, though this would take centuries, and melting the whole ice sheet would take a millennium. Long before that, though, we will have major problems, and not always the ones you hear about on the news. Ice melting leads to warming temperatures and rising sea levels, but a study earlier this year also found accelerating Arctic warming is likely responsible for severe winter weather in the Northern Hemisphere. The study in the journal Science explains how climate change increases the likelihood of winds above the North Pole being stretched, which in turn makes extreme cold weather events in the US and elsewhere more likely. Arctic warming is causing changes in its climate, such as melting sea ice and increasing snowfall in Siberia, which in turn means levels of energy and moisture moving between the surface of the Earth and its atmosphere are changing. Those changes kick the atmosphere, resulting in upward moving waves rippling into the stratosphere, where they stretch and weaken the band of fast winds that circles above the Arctic, known as the Arctic polar vortex. In addition, as the polar vortex shifts around, its effect on winds and temperatures means that the atmospheric waves which affected it are in turn affected by it and are reflected back down to the surface, where they can influence weather patterns. Summing up the seeming contradiction of warming causing colder weather, the study's author explained simply, when the polar vortex is nice and circular, that's a sign all the cold air is bottled up over the Arctic. When it stretches like this, a piece of it goes into Asia and a piece of it goes towards eastern North America. And that was what happened with the Texas cold wave. Climate scientists like those at NASA are clear that the trigger for the loss of such significant amounts of land-based ice is human-caused global warming. But other factors can exacerbate the problem. A Nature climate change study in 2020 found an underwater heat blob from the Atlantic is exacerbating the warming of the Arctic Ocean and thus contributing to the rapid disappearance of Arctic sea ice. That study showed that the amount of heat transported to the Nordic seas and Arctic Ocean by ocean currents has increased dramatically since 2001. This poleward heat transport has been implicated as one possible cause of the warming of the Arctic Ocean and the rapid disappearance of Arctic sea ice. As warm surface waters travel to regions further north, they lose heat and gain in salinity as fresh water evaporates. When warm Atlantic water reaches the Arctic, it sinks to form a heat blob because the cool fresh water from the Arctic is less salty and thus more buoyant. This facilitates the formation of sea ice over the ocean. However, the increased transmission of heat to northern latitudes could work with global warming to hinder sea ice formation. A massive melting event has affected Greenland's ice sheet during a heat wave that has brought temperatures more than twice as hot as seasonal averages, according to Danish researchers cited by Agence France Presse. Since Wednesday, the ice sheet has melted by close to 8 billion metric tons a day, twice its normal average rate during summer, according to tracking site Polar Portal website, which is run by Danish researchers. While this loss of volume was not as extreme as the largest single-day melting event in 2019, the researchers say the area over which melting took place is actually larger than 2 years ago. The amount of ice that melted on Wednesday alone was enough to cover the whole of Florida in 2 inches or 5 centimeters of water, and more than half of that mass will have flowed into the ocean, according to one climate scientist who spoke to Deutsche Welle. The Greenland ice sheet is the second largest mass of freshwater ice on the planet, according to Agence France Presse. It is made up of nearly 1.8 million square kilometers or 695,000 square miles of ice, second only to Antarctica. A study published in 2020 in the journal Nature stated that Greenland's ice is melting faster than at any point in the last 12,000 years, and a 2019 research paper in the journal Science Advances said that could add between 5 centimeters and 33 centimeters to global sea levels by the end of the century. The heat wave that caused the most recent burst of extreme melting is a result of a patch of high pressure sucking and holding warmer air from the further south over eastern Greenland, according to Marco Tedesco, a glacier expert at Columbia University who spoke to The Guardian. Linking these events to climate change, he added that although these atmospheric events have taken place in the past, they are now getting longer and more frequent. NASA explains that the levels of carbon dioxide in Earth's atmosphere have been increased through the burning of coal or oil, as well as the clearing of land for agriculture, industry, and other human activities. This makes the Earth's overall temperature higher, which in turn can cause sea level rise through the melting of ice, like that in Greenland. Worse news still is that this process will perpetuate itself, Columbia's Tedesco told The Guardian. He explained that because the snow on top of these ice sheets operates like a protective blanket, once that is gone, you get locked into a cycle of faster and faster melting. It's amazing to see how vulnerable these huge giant areas of ice are, he told The Guardian. This is, in short, a bad story getting worse. According to the U.S. National Oceanic and Atmospheric Administration, global mean sea levels has risen in total between 8 and 9 inches, or between 21 and 24 centimeters, since 1880, with about a third of that coming in just the last 2.5 decades. The rate of sea level rise has more than doubled from 0.06 inches or 1.4 millimeters per year throughout most of the 20th century to 0.14 inches or 3.6 millimeters per year from 2006 to 2015, and this is mostly due to meltwater from glaciers and ice sheets, as well as thermal expansion of seawater as it warms. A team from NASA has previously calculated that Antarctic and Greenland ice sheets together lost 81 billion tons of ice per year in the 1990s, compared with 475 billion tons of ice per year in the 2010s. This is a 6-fold increase. In total, Greenland and Antarctica have lost 6.4 trillion tons of ice since the 1990s. A number of different studies, including one published by the Danish Meteorological Institute, now say this places us at the high end of climate estimates for sea level rises. The action we need to take is clear, according to Tedesco. We need to get to net zero emissions, he told The Guardian, and we need to protect exposed populations along the coast. Keep watching to find out why the world's largest ice shelf breaking off Antarctica earlier this year wasn't caused by climate change and didn't cause sea levels to rise.
For more news animations and explainers, hit the subscribe and bell button to join the TomoNews family. Thanks for watching.